Hi, my name is Rogelio Garcia, and with collaboration of Dr. Tetiana Christoph and Dr. Jesus Palacios, we have developed the work Structural Characterization of Nanoscale Silver Particles for Biomedical Application. Recently, silver nanoparticles have been researched due to their variety of applications, for example in electronic, medical, and electrolytic industry. In medical field are used as antimicrobial particles, drug distributors, and biomarkers. Particularly, tuberculosis treatment has limited effectiveness and slow action, so encapsulation of silver nanoparticles on liposomes represents an alternative that reduces kidney and liver damage. Liposome structures limit the size of silver nanoparticles that can be encapsulated. This is the reason to research the morphology and size of particles that will be encapsulated. Silver nanoparticles used in this research were produced and given to us by colleagues of Taras Shevchenko, Ukraine National University. The particles were produced by a patented technique by electric spark underwater. The particles suspended in water were deposited by drying on a silicon monocrystalline substrate, and a portion of the suspension was centrifugated and deposited equally. Particles were characterized by energy dispersive X-ray spectroscopy, X-ray diffraction with different types of scans, atomic force microscopy, and scanning electron microscopy. Energy dispersive X-ray spectroscopy was done on spot mode and with a 10 kV acceleration voltage, revealing in samples deposited per se the presence of silver, nitrogen, carbon, oxygen, sodium, and silicon. In samples deposited after centrifuge was found silver, chlorine, sodium, silicon, and phosphorus. A standard X-ray diffraction scan did not show any peaks corresponding to silver in samples deposited per se. This was the reason refining the scan was necessary. The sample was fixed in an angle θ0 from 2 to 10 degrees and making the detector scan. The highest intensity peaks were found with θ0 equal to 3 degrees as shown in the picture 1. Peaks 111 and 200 are not in the proportion given by the crystallographic card, and with an inclination of 5 degrees relative to diffraction plane, peak 200 has maximum intensity and peak 111 has no intensity. This suggests the presence of a strong crystallographic orientation. These scans were repeated on different areas of the sample, showing the same results. These peaks reveal a 13 nanometer size in direction 111 and 24.9 nanometers in direction 200. Samples that were deposited after centrifuge were not possible to obtain peaks corresponding to silver with standard scan and detector scan, so they were analyzed using rocking curve scan as shown in picture 2. These peaks reveal a 292 nanometer size in 111 direction and 60 nanometers in direction 200. With atomic force microscopy were obtained topography pictures for both types of samples in intermittent contact mode as shown in picture 3. For samples deposited per se was obtained an average height of 24 nanometers and an average rugosity of 1.3 nanometers. For samples deposited after centrifuge, an average height of 83 nanometers and an average rugosity of 2 nanometers was obtained. With scanning electron microscopy were obtained backscatter electron images for both types of samples as shown in picture 4. Image reveal a nanoparticle size of 18.5 nanometers for sample deposited per se and superior to 100 nanometers for sample deposited after centrifuge. Particles deposited per se and after centrifuge were not possible to characterize with standard X-ray diffraction, and was required to do a refining of the scan used, also revealing the strong crystallographic orientation on samples deposited per se. Both types of particles were possible to be measured by X-ray diffraction, revealing that centrifuge maintained bigger particles in the suspension. Energy dispersive X-ray spectroscopy confirmed the presence of silver as from other elements that form additional compounds. Atomic force microscopy and scanning electron microscopy confirmed the size obtained by X-ray diffraction.